Welcome back, Focus Learners. Let's jump right into today's explainer. Today, we're cracking open a really fascinating syllabus on C programming, and we're zeroing in on functions. But instead of looking at this as dry academic theory, I want you to think of this as acquiring a brand new set of power tools for a massive construction project. I mean, when you build a house, you don't just pile up bricks randomly, right? You need a blueprint, you need structure, and you definitely need specific tools for specific jobs. That is exactly what functions provide in C. So we're going to break down the syllabus and show you exactly how to equip your programming tool belt.
Okay, let's dive into this. A user-defined function. Well, it isn't just a random snippet of code. It is a highly structured tool. And the absolutely crucial phrase here is created by the programmer. You aren't just relying on what the language gives you out of the box. You're actively engineering your own solutions to solve problems, develop logic, and execute specific tasks. When you create a user-defined function, you are literally inventing a new, custom tool tailored specifically for the job at hand. It's a real game changer.
So here is our builder's blueprint for this explainer. We'll start with the power of functions, explore their anatomy, and look at advanced features. Then we'll apply them to two practical tasks: calculating percentages and assigning grades. And finally, we'll wrap up with your self-learning challenge. Let's get right to it.
Section 1. The power of functions. Now, the true power of functions actually lies beyond just saving memory. It's all about usage. The ultimate goal is simple, yet incredibly profound. Apply functions to solve problems in C. Functions are basically the structural lifesavers that rescue programmers from the absolute chaos of messy, disorganized code. Without them, a program is just this massive, unreadable wall of text. But by applying functions, you gain the superpower of organization. You can isolate problems, tackle them one by one, and build a program that is both rock solid and easy to understand.
Moving right along to Section 2, Anatomy of a Function. Okay, so here are the core components you need to master. Think of function main as the general contractor of your program. It's the central hub where all the execution starts and where the big decisions are made. But the general contractor doesn't do all the manual labor themselves, right? That's where defining a function comes in. That's you building a specialized subcontractor to do one specific job perfectly. Accessing a function is simply the general contractor calling that subcontractor over to do their work. And the function prototype, well, that is your upfront blueprint summary. It basically tells the compiler before anything even runs, hey, just a heads up, I'm going to use a tool that looks exactly like this later on.
And this brilliantly illustrates the chronological flow of how a function actually comes to life in your C program. Step 1. You declare the prototype, giving the compiler that quick heads up. Step 2. You define the function, writing out the actual nuts and bolts of the logic. And step 3. You access, or call, the function, which finally puts all that logic into motion. Understanding this exact three-step rhythm is just essential for any C programmer. It's literally the standard operating procedure for every single tool you build.
Section 3. Advanced Function Features.
Now, the syllabus introduces 3 advanced features here. First up, passing arguments to a function. Think of arguments as the raw materials you feed into your machine. You hand the function a piece of data, it processes it, and then it spits out a result. Next is recursion. This is a fascinating concept where a function actually calls itself to solve a problem in smaller, repetitive layers. It's kind of like a giant puzzle. Finally, we have storage classes and their types. Storage classes are basically the zoning laws of your construction site. They dictate exactly where your variables live, how long they stick around, and who gets access to them. These are the advanced techniques that truly separate a novice coder from a master architect.
All right, Section 4, Task, Calculating Student Percentages. It is time to step directly onto the construction site. Our first practical task is to create a C program to calculate the percentage of a student using user-defined functions. This is a crucial logic-building exercise. You aren't just writing a simple math equation here, you are building a specific, standalone machine whose absolute sole purpose in life is to process raw test scores and output a clean, accurate final percentage. So, why does this specific task matter? Well, it proves you can actually develop and validate structured programs. By computing and displaying these percentages using a specialized function, you're demonstrating that your code isn't just working by accident, It is structured, it's logical, and it's valid. You are proving that you can completely control the flow of data.
Let's move to Section 5, Task, Assigning Letter Grades.
This next task is really the final polished stage of our construction project. It requires us to extend the exact logic we just built. Task 7 asks you to write a C program that uses a function to assign grades based on percentage. So you take the output from the previous task, that raw computed percentage, and you pass it right into a brand new user-defined function. This new function evaluates that number and assigns the correct letter grade. It creates this beautiful pipeline of logic where one tool feeds perfectly into the next.
Now, what's really interesting about this is how clearly it maps out the required logic flow. Your input is the student percentage. The action the function performs is evaluating that percentage via specified grading criteria, and the output is the assigned grade. This is exactly what the syllabus demands, applying functions to develop programs that evaluate and assign according to strict criteria. It represents perfectly structured, professional-grade code logic.
Section 6. Your Self-Learning Challenge.
The self-learning challenge is this. Write 2 programs using functions which have previously been written using loops. Think about your past programs that relied heavily on loops. We've all been there. Often it results in a tangled mess of repetitive logic if it's not managed perfectly. Now contrast that with the future, taking those exact same problems and rewriting them using your new function tools, resulting in a clean, stacked, structured architecture. It's the ultimate test of your new builder skills, essentially renovating old, messy code into something truly elegant.
Which brings us to our final, provocative thought for today's explainer. Look closely at your past coding projects. Can you rewrite your most complex, tangled loop into a clean, simple user-defined function? I strongly challenge you to open your C compiler today and find out. The tools are right there in your hands, the blueprint is clear, and it's time to start building. Thanks for joining me on this explainer, focused learners. Keep exploring, keep structuring, and keep coding.